I recently had the opportunity to be the first journalist to conduct independent range and charge testing on a Rivian R2. Those videos are already up here on State of Charge. However, while I was conducting my charging recordings, I noticed that one of the adapters that I used had an issue. One of the DC pins melted during the charging session. And I suspect that it was because of the high amperage that the R2 can draw and was drawing during this charge recording. Rivian wanted the R2 to charge as quickly as possible. There's two ways of really doing that: up the amperage or up the voltage, because volts times amps equals the kilowatt draw, the power the vehicle can charge at. And in order to keep costs down, Rivian decided to stick with the 400 volt architecture that it had in its R1 vehicles with the same voltage. Some new EVs now have 800 volt architectures, and they can charge faster even with lower amperage. But Rivian was sticking with the 400 volt architecture to keep costs down, and in order to get the vehicle to charge faster, they had to up the amperage, and they upped it up over 600 amps. And that's the issue here today. Many of the adapters on the market cannot allow 600 amps to safely pass through them without melting, like we saw with the Tesla adapter that I had. It was an older version of the Tesla adapter. The newer ones, that shouldn't happen with. This video here today is really to talk about the problems that electric vehicle owners may have if they're using either older adapters, non-safety certified adapters, adapters that can't handle the amperage that their electric vehicle is going to pull, because some of the new EVs on the market now can pull very high amperage, like the R2. And I don't want to see R2 owners or owners of any electric vehicles end up with serious problems because they're using an adapter that can't handle the current their electric vehicle will accept. But there's one thing I want to mention. I'm going to start this video off with a little bit of an adapter history section, really for people that aren't sophisticated electric vehicle aficionados, don't really understand this whole adapter thing. So if you do understand adapters and voltage and all that stuff, you might want to jump into about 10 minutes of this video. The first few minutes are going to be me just explaining why we even need adapters. With that said, let's get into it. All right, so first let's talk about the need for adapters briefly. So Tesla has always used its own connector. It was always referred to as the Tesla connector. Tesla renamed it the North American Charging Standard, or NACS for short, shortly before the industry decided to transition to using its connector. Why hasn't the whole industry been using one connector all along? Well, you'd have to go back to probably around 2010-ish, when Tesla was a young company and there really weren't other electric vehicles available from other brands. Nissan was making the Leaf, Chevrolet was selling the Volt, Mitsubishi was selling the iMEV, but very few companies were making electric vehicles, and there wasn't an established connector standard yet. The Society of Automotive Engineers was working on one, but they were going painfully slow, and I think Tesla just didn't want to wait, and they just said, we're going to make our own connector. We're not going to wait for the industry because everybody's dragging their feet on electric vehicles. We're going to transition the whole world to electric vehicles, so we need to worry about what we're doing. And they just went and engineered their own connector. It actually turned out to be darn good. While the industry was working on the J1772 connector for AC charging and CCS1 for North America, CCS2 for Europe. And that's how we've lived now since 2012 to 2 years ago to like 2024. Tesla used their connector. Everybody else used J1772 and CCS. But then a few years ago, Ford's CEO Jim Farley announced that the company was going to be transitioning to the NACS connector. And then everybody else did. It was a fait accompli at that point. Once one major player said, we're going to switch over, everyone was going to, because it gave them a competitive advantage. Not only were they using this, what I believe to be is a superior connector, but that also came with access to the Tesla supercharger network, which is expansive and very reliable. Okay, so everybody decided they're going to switch over to the NACS connector. Now we've got this field of vehicles that some of them use the NACS, some of them use CCS, but gradually all of them were going to have access to the Tesla supercharger network, which only had NACS connectors. A small number of them had Magic Dock, which had a built-in CCS1 adapter, but the vast majority of the Tesla superchargers, in order to use your non-Tesla vehicle there, you needed to have an adapter. And the NACS to CCS1 adapter was invented, and everybody wanted one. If your electric vehicle had a native CCS1 inlet, so many people went out and bought these because they wanted to get access to Tesla superchargers, and you needed one of these to do that. So a whole bunch of them came to market, some of them higher quality than others. But at the time, there was no safety certification for these adapters. There was no such thing as an adapter safety certification. Underwriter Laboratories, UL, hadn't written the rules for how adapters should be safe. They have since. It's called UL 2252. But a whole bunch of companies came out with these. Some of them were terribly low quality. I've always maintained that there's three adapters I'm comfortable with. That would be the Lectron Vortex Plus, the A2Z Typhoon, and the Amphenol adapter. These three are high quality adapters. I'm comfortable with them. There are literally dozens more that you can buy on Amazon for much less, but I haven't used them. I haven't reviewed them. A lot of them are extremely low quality. I urge my followers not to use anything but these three. I'm very comfortable that these are very safe, high quality adapters. Okay, well, that was the NACS to CCS1 adapters. But now, electric vehicles are beginning to come out with native NACS inlets. As the industry announced it was going to be transitioning to NACS 2 years ago or so, 2 years ago-ish, it takes a few years for the electric vehicles to then have their native NACS inlets, but now we're seeing them. Now, almost all the new models that launch have NACS inlets, so they can use Tesla superchargers without an adapter. But what if they want to use an existing CCS1 charger? Now they need the opposite adapter. And that's a CCS1 to NACS adapter, which is what I used when I was charging at a Walmart 400 kilowatt DC fast charger with the R2. The reason why I use that one, and the interesting thing is all Walmart chargers have NACS connectors and CCS1 connectors. So why didn't I just use the NACS connector? I wouldn't even need an adapter. That was because Walmart uses two brands of chargers. They use the Alpatronic HYC 400. That charger can deliver 400 kilowatts on either the CCS1 side or the NACS connectors. And both are rated at 600 amps. That's what's important, that they can both deliver 600 amps. But Walmart also uses the ABB A400 chargers at some of their locations, which is where I was at this point in Colorado Springs. They use the ABB chargers. On those chargers, on the CCS1 side, it can deliver 600 amps. But on the NACS side, it can only deliver 375 amps. And therefore, I wouldn't have gotten the perfect charging curve that I wanted to achieve on the R2. Most owners will use that side and they will barely notice a difference. It might take them 2 minutes longer to charge. But for my charge recording, I really wanted to get it to be perfect, which I got a perfect charging curve out of it. I needed to use an adapter. And because of that, I took a couple of adapters because I was concerned from the beginning, because the fact that the R2 can pull up to 630, perhaps even 650 amps. Rivian has told me it can accept up to 630 amps. I have reason to believe that it's possible that it can, at certain circumstances, accept up to 650 amps. And that's part of the reason why Rivian's building out its Adventure network to deliver up to 650 amps. None of the other charging networks out there currently can reliably deliver 650 amps to a Rivian R2. In fact, all of the networks are capped at 500 amps. When the units have the ABB A400 chargers and the Alpatronic HYC chargers in use, they can deliver up to 600 amps. But if you go to like a EVgo site or an Electrify America site, for instance, you're going to be capped at 500 amps. So it won't be a problem. But since I used an adapter on this charger that was delivering 600 amps, and the unit was calling for at least 600 amps. The R2, was calling for at least 600 amps. What happened was one of the adapters that I used, this one here, this is an adapter that I bought from Tesla. The pin melted on it. Now it was able to complete the charging session, but the pin melted for sure. You can see that here in this picture. And on a subsequent charging session, I used the Lectron adapter. And while I was charging the R2 with this adapter, I got a notice that the charging rate was slowed because the adapter was too warm. So the adapter was starting to exceed its safe limits, and it lowers the charging rate so that there's no problem. That didn't happen with the Tesla adapter. It kept accepting the power and it melted. Okay, so this led me to say, okay, we need to have a conversation about this. And the R2 isn't the only electric vehicle that can accept over 600 amps. Most electric vehicles can't in America today. There are some Volvo and Polestar vehicles that can accept over 600 amps for a short period of time. And Tesla vehicles can accept over 600 amps. But the thing about the Tesla vehicles is most Tesla owners are charging snobs. And I mean that in a good way. They'll only use Tesla superchargers. And Tesla superchargers were designed to charge Tesla vehicles, initially at least. Tesla's vertical integration, they make the chargers, they make the cars, they make the software, they make the adapters. Everything's going to work perfectly together because it was designed to work together. And if you own a Tesla vehicle and you're charging on the Tesla supercharger network, you won't need an adapter. The Tesla sells this for its customers to charge on CCS charging stations. And up until recently, there were no CCS charging stations that could deliver more than 500 amps. So this adapter here, I bought from Tesla like 3 years ago. This is their older version of the CCS1 to NACS adapter. They sell a new one now that is more robust. It is made to UL 2252 standards and conform to the J3400, which is it's basically the NACS connector, but it's made a little bit more robust. And it can handle, I suspect, it can handle over 600 amps. But the older versions of the Tesla CCS1 to NACS adapters evidently can't. So I wanted to make people aware of that. I also wanted to make people aware of the fact that there are other high quality CCS1 to NACS adapters that can handle 600 amps. Maybe not continuously, but they can handle it for a short period of time. And when there's an issue, they'll derate, as we saw happening with the Lectron adapter. Now, Lectron is a contract manufacturer. They make adapters for almost all of the industry right now. If you have an electric vehicle and it came with an adapter, whether it's a NACS to CCS1 adapter or a CCS1 to NACS adapter, chances are it was made by Lectron. They make like, I think 90% of the manufacturer supplied adapters. Now, you won't see Lectron written on it anywhere. The manufacturers don't like to say that they don't like to talk about who they use as their contract manufacturer, but they do. The other adapter that I believe is a very high quality is the A2Z adapter. A2Z is also a contract manufacturer. If you ever saw any of the DeWalt products online now, the DeWalt adapters, A2Z makes their adapters. It's not made by DeWalt. It's just a rebranded A2Z adapter. And these I'm very comfortable with, as sure I am with the new Tesla adapter. I just don't have one here. But I would recommend, if you have an electric vehicle that can accept more than 600 amps. The new BMW vehicles can, as I mentioned, some of the Polestar and Volvo electric vehicles can, and particularly an R2, which will accept more than 600 amps for a sustained period of time. I highly recommend either using the supplied Rivian adapter, and I say supplied adapter because Rivian does supply the adapter to customers that live in CARB states. Let me explain that. So if you live in one of the 13 CARB states, you'll get the adapter for free. Also, the AC charging adapter and the portable Rivian charger. That's because the CARB states require it by law that the electric vehicle has to come with a charger and an adapter. So Rivian will give you the CCS1 to NACS adapter and a portable charger for free if you order the vehicle and you live in one of those 13 CARB states. But if you don't live in one of the CARB states and you don't get the adapter free from Rivian, I recommend that you buy the Rivian adapter. And that's because the Rivian adapter is a high quality, safety certified adapter made by Lectron. It's this adapter here with a Rivian name on it. Now, Lectron hasn't told me that, Rivian hasn't told me that, but I know it's the case. And those adapters have been tested and certified to be able to withstand over 600 amps for a short period of time, and then they derate. As a matter of fact, Lectron has sent me the engineering reports on that. I'm not allowed to show it here. It's proprietary information, but they showed me the cutoff points where when it hits a certain temperature, it derates. If it hits even higher in temperature, it shuts off. And it's specifically designed to be able to hand high amperage draw, as is the A2Z adapter. And I've actually spoken at great lengths to both companies. And Lectron gave me a statement, which I'm going to read here. Our CCS to NACS adapter is UL2252 certified, SAE J3400 compliant, and has undergone automotive grade validation testing beyond certification requirements. Multiple safety features, including thermal monitoring and automatic derating, help ensure safe operation during high amperage DC fast charging with all NACS EVs. I also spoke with the CEO of A2Z EV about this issue that I had with the R2, and he sent me a lengthy reply on why he's confident that his adapters are engineered to withstand the current that the R2 or any electric vehicle that you could buy here in North America today can ask for. So let's take a look at that. At A2Z EV, we are committed to the highest standards of quality and safety. Internal teams, CSA, and various OEMs have thoroughly tested our adapters, pushing them well beyond their limits. Because of this, A2Z EV offers the most UL2252 certified adapters on the market. Our products not only comply with the J3400/1 standard, but they are also fully certified by CSA under UL2252. Additionally, our adapters feature multiple internal thermal switches. On our DC models, these switches dynamically adjust the proximity circuit resistance loop, communicating thermal status levels to the vehicle to orchestrate automatic thermal foldback or invoke a complete safety shutdown of the charging process if temperature thresholds are breached. We evaluate and test every adapter using more than 10,000 plug cycles, temperature rise assessments, conductor and continuity resistance checks, insulation resistance testing, IPX evaluations, flame retardant trials, and much more. As an SAE J341/1 member, A2Z EV remains dedicated to adhering to the latest and highest safety standards to protect the public. We strongly advise EV drivers to purchase certified charging equipment only from reputable brands, manufacturers, or OEMs. Be cautious of false UL2252 certification claims. A legitimate brand will always provide a valid certificate number for an advertised certified product. It is important to know that a test report does not equal full-scale certification. Purchasing cheap, untested products poses serious safety risks. And A2Z EV further stated, in internal temperature rise testing at an ambient 27.3 C, the CCS1 to NACS thunderstorm adapter sustained a continuous 600 amp load for 2 hours and 16 minutes. The adapter's thermal protection system began current foldback approximately 16 minutes into the test, with full over temperature switch activation occurring later as the junction approached its 99 C set point. Throughout the entire 600 amp test, the external surface temperature never exceeded 53.2 C. This is an important topic. You can buy one of these adapters on Amazon for under $100. As a matter of fact, there's one I think for like $69. But I guarantee if you use that adapter on an R2, before too long, it's going to melt. Something inside that adapter is going to fail, and you're going to have a problem. And you know, if you damage a charger, the connector head or something, the company can go after you. I don't think they will, but they can. And all of the major networks have policies on adapters. And I've researched this. So let's take a quick look at what the networks have to say about third-party adapters. EVgo says only UL2252 certified adapters are allowed on its network. IONNA says only the adapters that are sold or provided to you by your vehicle manufacturer are allowed on its network. Electrify America says only adapters that are authorized by automakers for use on that specific vehicle and are UL2252 certified. Tesla says the adapter must be provided by Tesla or your vehicle's manufacturer. And I also reached out to Walmart for clarity on this because Walmart doesn't have it listed anywhere on its website. I haven't received a response yet, but the fact that it doesn't state that it's not allowed, that you can't use third-party adapters, I suppose legally you could use anything you want. I'm sure at some point Walmart's going to clarify that, and they're not going to allow adapters that aren't safety certified or provided by your manufacturer. But for now, Walmart doesn't have an official position on adapter use on its network. So you could see there that there's no one clear policy. Some of the networks require the adapter to be UL2252 certified. Some of the networks require it to be UL2252 certified and supplied by your manufacturer. And other ones just say, well, if your manufacturer gave it to you, it's okay, you can use it. And the crazy thing is, there are adapters out there that have been supplied by manufacturers that aren't UL2252 certified. And that's because these adapters have been being sold and handed out by manufacturers for a couple of years now, before UL2252 even was formally adopted. So they couldn't be UL2252 certified. There was no certification at the time. So what am I saying here? Well, what I'm saying is basically is make sure you have an adapter that is UL2252 certified. Even if you received it from your automaker, if it's a couple of years old, like this Tesla adapter, it may not be able to sustain higher amperage that the newer electric vehicles can accept and the newer chargers can deliver. You know, this wasn't a problem a couple of years ago because there were, outside of Tesla vehicles, there were no vehicles that could accept over 600 amps. There were no chargers that can deliver it. But now we're getting higher powered chargers that can deliver more power. Electric vehicles can accept more power. And now this is becoming more of an issue. So make sure that your adapter that you're going to use is UL2252 certified, or it's one that you received from your manufacturer within the last year, I would say. If you received it before 2026, there's a high probability that it doesn't meet UL2252 standards and it's not J3400 compliant. So that's something that you'd want to definitely check out because you can have a serious problem. It could damage your vehicle. It could damage the charger. And like I said, if you damage the charger, it's in the terms of use of all the networks. They can make you pay for it and it would be very, very expensive. I think it's unlikely that they're going to go after you, but they could. It's in their terms of use. All right, so if you are in the market for an EV charging adapter, I urge you not to just go to Amazon and filter by lowest price. Those really inexpensive adapters are super cheap. Yes, they'll work for a while, but eventually, if you have an electric vehicle that's going to pull high current, you're going to have a problem with it. It's going to, at the least, it's just going to melt internally and you'll have to buy a new one. But it could actually fuse the pins to your electric vehicle. The adapter could be stuck in your charge port. And now you're in for many thousands of dollars of repairs. That's not going to be covered under the warranty. It could also stick to the CCS1 connector. I'm surprised that this Tesla unit didn't. It actually was a little tight to pull off because the pins were melted. It was starting to fuse to the CCS1 connector. I've already notified Walmart about this. They know that this happened and they sent somebody to inspect the station. I also sent my Lectron adapter back to Lectron, even though I was confident that there was no issue with it. I did send it back to them to open it up and inspect it because, the charging rate did slow down. It said adapter getting too hot. We're going to slow down the charging for a little bit. I just wanted them to take a look at it. They sent me another one, just complimentary. They were thankful that I sent it to them because, they're on top of safety. It's one of the reasons why I recently went to the Lectron factory to look at their quality control processes. I produced a video on that, and it's here on State of Charge. But I wanted them just to take a look at it, just to be certain. They actually replied that it wasn't necessary, that they're sure it's going to be fine, but they said send it back anyway. We'll send you another one just to be extra safe. And as I said, they're the company that makes the adapter for Rivian, so I am sure they've fully tested it with the R2 that can accept high power. Both they and Rivian have at this point. So if you have the Rivian branded adapter, I'm sure you're going to be fine. I just don't want people out there using low quality third-party adapters that are going to have issues. Last thing I want to see is somebody get hurt or their car get damaged. All right, well, that's pretty much all I have here today on this adapter safety video. This is an evolving industry. Chargers are delivering more power than ever. Electric vehicles are accepting more power than ever. So there's going to continue to be issues like this that need to get brought to light. And if you understand what's going on with your electric vehicle, if you understand there's a difference in these adapters, that the ones that cost $70 are not the same as the ones that cost $200, at least you can make the right decision and use the right equipment on your electric vehicle and not have any problems. All right, well, that's all I have here today. If this is your first time here at State of Charge, please hit that subscribe button and ring the notification bell so you don't miss any upcoming electric vehicle news and reviews. And as always, thanks for watching.